Okay, so I want to take some time to reflect on three calculations: distance, midpoint, and slope. These are three calculations that students sometimes get wrong on a test, and it's not because they're difficult, it's because they're making sign errors or silly mistakes. So I really want to focus in on this. Let's start together. I was trying to find good graph paper, but I hope you can see this okay. I made the little tick marks, 1 unit each. So go ahead and let's take the point A. Let's have it be 2 comma 4. Okay, go ahead and plot that. All right, so it's over 2 up 4. So it's right here. That's point A. See, I have the tick marks like that. 1, 2, 1, 2, etc. Okay, then go ahead and take the point B. Let's have that be -3 comma -2. Plot that. Okay, back 3 down 2. So that's right here, point B. Go ahead and connect the dots. I'm going to do that in another color. Okay, so we have a lovely line segment, AB. My first question is, what is the distance from point A to point B? Now, you might be eyeballing it. In fact, you might even be thinking of Pythagorean theorem. I did want to mention, if you're a very visual person, you might be remembering something about leg, hypotenuse, and you might be remembering, that leg squared plus leg squared equals hypotenuse squared, Pythagorean theorem. And that's great. It'll definitely lead you to the length of the hypotenuse, which is the distance from point A to point B. But I want to temporarily dodge that. Okay, so I'm going to erase this part here. Let's see if it'll let me bring back my axes. So I want to just, although I could, do this with Pythagorean theorem, I want to think about it just with my distance formula. Now, let me flip to the next slide for that. See, here I take inventory of all the formulas we're going to need. So we need the distance formula. And, if you're a person, notice all the subscripts, but it's going to be plug and chug. So if you're a person that likes plug and chug, you'll like this, okay? So let's go ahead and label this point x1, y1, and this point here x2, y2. And let's start, practicing plugging into the distance formula. So distance is big square root, x2 minus x1, whole thing squared, plus y2 minus y1, whole thing squared. So as long as you don't make any sign errors, and as long as you, go through that systematically, you'll be fine. Okay, so -3 minus 2, whole thing squared, that's my change in x, plus change in y, -2 minus 4, whole thing squared. Okay, if you keep crunching that out, all right, let me grab my eraser here. If you keep crunching that out, you're basically going to get that the distance is the square root of what? Well, -3 minus 2 is -5, and then squared is 25. So 25 plus, and then -2 minus 4 is -6, but squared is 36. So you're basically getting that the distance is the square root of whatever 25 plus 36 is, which is 61. Okay, but root 61, let's think about that in decimal form. So let's see, the square root of 49 is 7, and the square root of 64 is 8. So you're probably thinking about, and you can type that out and get a decimal. I'll type it out right now, in fact. So root 61, about 7.8. So what that basically means is the distance, let me highlight it here, from here to here is about 7.8 units. And you know what? That makes sense. Even if you just use your fingers and gauge it, that makes sense. So approximately 7.8 for the distance. In other words, if we would have gotten the answer like the distance is 50 units or something, I would have known that was wrong. There's no way the distance from point A to point B is 50. Okay? And if we would have got the answer of like 1 or something too small, or 2, I would have known that was wrong. So just always check that your decimal makes intuitive sense. Okay, now let's think about the midpoint. Okay, and for the midpoint, let's see if I can do this in another color. I'm going to bring in, let's see, maybe yellow. For the midpoint, you eyeball it and you say, I think the midpoint lives right about here. Let me write this on here. M for midpoint, right about here. You say, well, just by eyeballing it, what's the coordinates of that? I don't know, maybe negative 0.5 comma 1, something like that. But that's guesswork. So you say, okay, I bet you there's a formula for calculating midpoint. So now that's going to be our next calculation. So let me flip to my inventory page. So here is the formula for the coordinates of the midpoint of a line segment. So x1 plus x2 over 2, y1 plus y2 over 2. Remember, that's giving you the coordinates of the midpoint. So let's try it. Okay, I'm going to record the formula. Always practice just recording it. x1 plus x2 over 2, comma, y1 plus y2 over 2. And again, you can put your parens, if I could squeeze them in there, for knowing that it's an ordered pair. All right, here we go. So take your two x's and add them together. So 2 plus negative 3 divided by 2, comma, 4 plus negative 2 divided by 2. Okay, if you crunch that out, what are you going to get? Well, and I'll put that in a lovely bubble right here. You're going to get 2 plus negative 3 is negative 1, so you're going to get negative 1/2, comma, and then 4 plus negative 2 is 2, and then divide that by 2, you're going to get 1. So negative 1/2, comma 1 for your midpoint. And you know what? That makes sense. That's what I thought if you look at this yellow dot, it looks like it is at negative 1/2, comma 1 right here. Now I changed it to a red dot for the midpoint. So big thing is sense. It makes sense. All right. So in other words, if I would have got a midpoint that was like negative 5, comma 8, I mean that's not even it's off the chart. It's not even on the line segment. So your answer should make sense. Okay. Now the fun part, calculating slope. What if I want the slope of this? Say I continue, let me change this to black. Right now it's a line segment, but we know a line continues forever in both directions, right? So what if I want the equation of the line AB? Then what must I do? Well, you'd have to calculate slope first. So let's take a look. Oops, let me hit pause. Okay, so again, to find the equation of the line, we must first find the slope of the line. So let's go to our formula page. Okay, slope. Slope is change in y over change in x. Again, the subscripts, y2 minus y1 over x2 minus x1. So it's definitely a lot of plug and chug in this segment. Okay, in this podcast. All right, so first, let's just practice getting the slope of this line. So y2 minus y1 over x2 minus x1. Okay, so then negative 2 minus 4 over negative 3 minus 2. If I keep crunching that out, well, that's negative 6 over negative 5. Negative over negative is a positive, so I know the slope is 6/5. Now, see, the thing is, even the slope, you even don't want to take that for granted. Meaning what? Slope is rise over run. So you can actually take this point B here and the point A, and you can check the rise. 1, 2, 3, 4, 5, 6. Rise of 6. 1, 2, 3, 4, 5. Aha. Run of 5. So in other words, you can visually check that the rise over the run makes sense. 6 over 5. Check. All right. So now we say, okay, we know the end game. If you want to get the equation of the line, the end game is y equals mx plus b. And we know the slope. We just figured it out, 6/5. But how do you get the b? Well, we might as well finish this off and let me add to our formula sheet. So since there's not enough room on here, if you want to get the full-blown equation of the line, y minus y1 equals mx minus x1 is going to get you the equation. That's called point-slope form. I like to think of it as an avenue. It's just an avenue to get you to y equals mx plus b. To get you there. To what you want, that y equals mx plus b. And you say, well, how is it an avenue? Well, all we have to do is plug something in for y1, plug something in for the slope, plug something in for x1, and we'll have it. Okay, so let's try it. What was our y1? And I'll highlight it here. Our y1 was 4, and our x1 was 2. Okay, so our y1 was 4, and our slope we had said was 6/5, and our x1 was 2. You arrive here on a test, you're pretty much right. It's just that you need that final answer in y equals mx plus b form, so keep cleaning it. So you've got y minus 4 equals 6/5 x minus, don't be afraid of the fraction, 6/5 times 2 is 12/5. You can either think about that or type that out in the calculator. And then right at the end you add 4 to both sides. You want to get y by itself, that's the goal. And then whatever negative 12/5 plus 4 is, which I believe is 8/5. Oops. I must have written the wrong thing. Yeah, negative 12/5 plus 4. Yeah, 8/5. And like I said, you can type that out or think about it however you like, but 8/5. So then, I'll put this in another color. So then final answer for y equals mx plus b form is that y equals 6/5 x plus 8/5. And if you think about it, here's how you know you're right. 8/5 for a y-intercept, well, that's like 1 3/5, right? It's a little bit more than 1. So you look back at your graph and you say, is the y-intercept a little bit more than 1? And you say, yeah, it looks like, it looks like it hits here. Now, I don't have it, perfectly sketched to scale, but y-intercept makes sense. It's definitely above 1. Okay. All right, so the main thing is, us getting used to using all these formulas. Right there was 4 formulas, and I'll just recap them. Distance, midpoint, slope, and then, of course, point-slope form is just this avenue that will eventually lead you to y equals mx plus b form if you plug everything in the right spot. Okay, hope that helps.